Here we'll do a more advanced variation on division combinations. We are asked to find g over h of x and its domain. We'll start with gx over hx. We'll note that g is square root of x minus 4, and h is 1 over x plus 5. We'll place that into the fractions. Therefore, gx becomes square root of x minus 4, and hx becomes 1 over x plus 5. Now notice that our answer looks kind of ugly right at this moment. We have a root divided by a compound fraction. When you have a compound fraction, we have to be careful, because before we continue any further, we have to know the domain of both pieces of this combination before we try to evaluate the combination. Therefore, before trying to find the domain of g over h of x, we have to first get the domain of g and the domain of h. So even though we now know what g over h of x is, we first have to inspect gx and hx. Note that gx is a root, and therefore we'll use the root rule that the inside of that root, x minus 4, must be greater than or equal to 0. For hx, we have a fraction, and that denominator must be not equal to 0. So we'll say x plus 5 cannot be 0. Now we try to solve it. If we have x minus 4 greater than or equal to 0, we'll add 4 to both sides and say x is greater than or equal to 4. Now we look at our denominator. We'll have x plus 5 is not equal to 0, and we'll subtract 5 from both sides, and we'll say x is not equal to negative 5. Now that we know the conditions that surround both g and h, we'll try to do the algebra to simplify our new combination function. We'll copy all of that onto a new slide now. Now we'll try to simplify the compound fraction in our new combination function. Anytime you have a compound fraction in the denominator, we will use the rule which we call keep, change, flip. The keep part of this rule says that we must keep the numerator the same. The change part of this rule means that we're going to change the big division bar in between the functions to multiplication rather than division. Finally, the flip part of the rule means we'll flip the fraction on the bottom over to make it x plus 5 over 1. The way this will look after we've done all of our operations is that we will still have square root of x minus 4. We'll change the big division bar to a time symbol, and then we'll flip the fraction on the bottom, which I'm circling now, to make it x plus 5 over 1. Now, when we multiply, we would ordinarily put a parentheses around the x plus 5. So we can now say g over h of x is now x plus 5 in parentheses times square root of x minus 4. Now let's check the domain of this new combination. Inside of this combination, we have no fractions anymore, and we have no logs, but we still do have a root, and we remember the root rule says that the inside of that root must be greater than or equal to 0. Therefore, we'll say x minus 4 is greater than or equal to 0, but we solved this on the previous slide, and we showed that x is greater than or equal to 4. This is the domain of the new combination. So now on the final slide, we will combine all of the domain information that we've obtained. the gx domain and the hx domain, along with our new combination domain. Here on this new slide, I've rewritten all of our domain information along with a number line. Let's begin with the first condition. Since gx must have an x greater than or equal to 4, we'll remind ourselves that greater than or equal to means we have a closed circle and we will go right. We place our closed circle at 4 and we draw a right-hand arrow. We then note that everything that is not part of that arrow cannot be part of the answer. Our second condition says that x cannot be equal to -5. We also recall that the not equal to symbol means we have an open circle, and that would ordinarily split the domain. However, notice that -5 is in the area we've already x'd out. Therefore, it will not affect the domain this time. But be careful, because when you do a combination function, you could get an open circle that's inside of the green zone, and that would affect the domain. Now, if we look at our new combination function, g over h of x, we have that x is still greater than or equal to 4, which we already knew previously. However, this also will not happen every time, so always check your combination functions as well. In this particular instance, the only region for our solution set is 4 to infinity, which I'm labeling with A now, and we'll say our domain for this new combination is 4, infinity, with a closed bracket on 4. And this is how we find the domain for a division combination that gave us compound fractions. The moral of the story is always be careful about checking for compound fractions when you do division combinations.